Maxwell's equation in free space. That is del dot E is equal to 0. Or sorry, this is rho by epsilon 0, and del dot B is 0. Your curl E is equal to minus del B by del T, and a curl B is mu 0 J plus epsilon 0 del E by del T. This term is your displacement current term. Okay. On it, this term your displacement current density term. So, while deriving these four equations, we will find some problem of symmetry, whether symmetry is obeyed or not, whether phase difference constraint is avoided or not, whether degrees of freedom constraints are avoided or not. The most important thing is, in a Lagrange's equation, you have shown the configuration space. That is a 3n dimensional space of having n number of particles, and each particle has 3 degrees of freedom. And that is a configuration space. So, your Lagrangian in configuration space makes a interaction between coordinate q and a velocity term q dot through an equation d by dt del L by del q dot minus del L by del q. But in Hamiltonian case, where L was t minus b, in Hamiltonian case, you cross over that to a phase space. And in phase space, what do you find? The coordinates and momenta are interdependent. And Maxwell's equations suggested that in configuration space also, the electric fields and magnetic fields, they are interdependent. They are interdependent, provided they are not steady fields. They are time varying fields. That's why he tried to make derivations of different electromagnetic equations. And Maxwell's first equation is coming from your general prospect of electric flux. First equation is coming from law of electrostatics, that is electric flux. You know Gauss law of electrostatics. Gauss law of electrostatics suggests phi is equal to q by epsilon 0, and phi can be written as integration of E of ds is equal to q by epsilon 0. Okay. Yes. Q can be written as in terms of rho, that is volume charge density. You can express this as integration over volume. Q can be written as rho dV. We can write rho is q by dV into dV. Okay, divided by epsilon 0. Now you apply Gauss divergence theorem. When you apply Gauss divergence theorem, E n cap ds can be surface integral, can be converted to volume integral. So you can write this one as del dot E into dV. Okay. By Gauss divergence theorem, this can be written as integration over V del dot E into dV. It's not it. And now you compare. Within 3 lines I am proving. No more, much more statements. We know what is electric flux from Gauss law definition. Flux is equal to q by epsilon. Then I convert q in terms of rho volume charge density. Then I apply Gauss divergence theorem. E n cap ds, which gives del dot E dv, and after comparison of these two sides, you can say this is nothing but your first law of Maxwell's equation. Are you clear from this? Then we will proceed to the second law. जति कहबा सेति भलो भाबरे कहबा हैना मु प्रिपेयर अछि 3 आवर्स खंड जाय मु कहबे 12:40 खंड मु छाडिले मु 2टा बेले पुनी केन्द्रापड़ा कॉलेज रे 3 घंटा क्लास में पीजी क्लास है आज मंगलवार तेणु मु 2टा 5टा सेठी क्लास में एटी मते घंटे 10 मिनिट लागियो तो 10 मिनिट खाई तापरे 2टा तापरे सेकंड लॉ क्लियर फर्स्ट वन second law del dot b is equal to 0 del dot b is equal to 0 किस समय दबा 5 मिनट्स खंडे del dot b 0 नुआ कथा किछि ना खाली जस्ट रिप्लेस केमते माने रखिबो रिप्लेस इलेक्ट्रिक फील्ड बाय मैग्नेटिक फील्ड what you have to do replace electric field by magnetic field पिला गॉस लॉ ऑफ मैग्नेटोस्टैटिक पढिछु net flux magnetic flux linked with a closed surface Biot-Savart's law in relation with Biot-Savart's law you will find instead of E and ds this will be just I'm changing con change out today b n cap ds
is equal
in
to
a
0
closed surface is
0
and what is b n cap ds can be written as del b dv cross divergence theorem which indicates the second one kete sahaj re jaଉଛି dekhu
yes sir
del b is equal to 0 is not it you will accept or not accept
yes
very small lines two lines very similar equations only you have replaced e by and what is its physical significance? It is suggests magnetic monopole does not exist. A single pole cannot serve. Minimum 2 poles are necessary. But magnetic jete katti gale 2 pole bhar. But south pole but north pole 2 poles are necessary. Okay. The third equation that is your electromagnetic equation given by Faraday that is equal to curl E is minus del B by del T. This equation.
yes
How can we arrive? I could take all the abstract figure from the concept of here Faraday's laws of electrophysics. हमें मैंने जानी छे E is equal to minus d phi by dt where E is equal to induced EMF. E is equal to our
induced EMF
E is equal to d phi by dt. पूर्व equation में देखिल phi is equal to integration of ds. So this can be written as minus d by dt integration d by dt dv by dt into ds. No.
yes
And you know E can be written as E का कुछ कौन लिखिचु E can be written as
dv by dt
E को केमते लिखिचु
phi by dt
EMF को केमते लिखिचु ना इंटीग्रेशन E हला पोटेंशियल E is equal to कौन तू पढ़िचु जे इलेक्ट्रिक फील्ड इंटेंसिटी माइनस dv by dt माइनस dv जगह रे पोटेंशियल जगह रे तू नेचु E is equal to minus v. So this is E dr or E dl you can take.
EDM
बुझ पड़ला ताले E जगह रे E dl integration E dl is equal to minus d phi by d. तापरे तू सेठी दीटार गॉस डाइवर्जेंस अप्लाई कर एठी कोन अप्लाई कर स्ट्रोक्स लाइन इंटीग्रल टू
surface
ताले एठी कोन हे जिवो बाबू एटा सरफेस इंटीग्रल अछि आकु कन्वर्ट कर देबो इंटीग्रेशन कर्ल E न रे कर्ल E ds by Stokes. This is by Stokes theorem. So this is equal to minus oh एठी दिथर हे सर minus integration minus del B by del T ds. What does it indicate? Comparison कौन दो? Curl E is equal to minus del B by del T. Taken?
Yes.
देखो तो कितना सहज
Yes.
by 3 or 4 lines we are arranged एवं एटा सबुबले परीक्षा पड़े Maxwell's equation जीवु तो देखि गोटे लॉन्ग क्वेश्चंस थी हैला तीनटा है गला समस्तार ना कार असुविधा अछि फोर्थ इक्वेशन को जिबा गोटे बेसी आरे टिके केवल सेठी दीटा रे गॉस डाइवर्जेंस थ्योरम अप्लाई करछो एठी बड़ा
Stokes theorem.
Now come to fourth one. Fourth one is Ampere's circuit law.
Ampere's hospital law.
Can I erase this?
Yes.
Then fourth one suggests करुचे जे integration over C into b dot dl. This is Ampere's circuit law is equal to mu 0 ಇಲ್ಲ I को मु कोन लिखिबी हमें करंट डेंसिटी वेक्टर जानि छ J is equal to I by A और I is equal to J dot dA और I can be written as surface integration of J n cap ds. I can be written as this. So you put this value of I and it gives integration b dot dl is equal to mu 0 J times n cap ds. What will you do now? Apply Stokes law. Which got the first beta Gauss divergence apply to. Second is the Stokes. Idea clear? Then we will apply Stokes law. Integration curl B ds n cap ds is equal to mu 0 J n cap ds. Are you fine? Then curl B is equal to mu 0 J. कर्ल B is equal to कौन mu 0 एतिक थिला तापर एटा केबे आसला देखि ओके now the concept of displacement vector came and there is it needs a modification of the Ampere's circuit law. Ampere's circuit law एतिक थिला ना कर्ल B is mu 0 J. So when people find that this is a capacitor. These are two capacitors, and this is the circuit connected to a battery having a resistance. So whatever it means. So what happened? The capacitor has a surface area. This is the surface area of one side, and this is surface area of the other side. And what happens in between there is vacuum. So the current I which flows up to this one and cannot flow in the vacuum because there is no medium. But there is an interaction between the 2 points of electric field. And the time varying fields are capable to produce that current which flows through the vacuum known as displacement current. So, modified Maxwell suggested Ampere's circuit law that I is not equal I plus ID is the total current flowing through the circuit. It is not I but and ID is called displacement current. And where does this displacement current come? Now, if it is a capacitor, then it will store some amount of charge. What is that charge? Let it holds charge Q. And potential difference between these two surfaces S1 and S2 or between the plates is V, then charge Q should be CV. Where C is the capacitance, V is the potential difference between the plates. Then corresponding current, you can say what is C? If it is a parallel plate capacitor and D is distance of separation between two plates and A is the area from our plus 2 knowledge, we know capacitance is epsilon 0 A by D. What is potential? Pila potential हमें कौन पढ़िचे? Potential is equal to कौन पढ़िचे? V is equal to ना IR formula इधे use होगा. तब पढ़िचे E is equal to V by R. So D is the distance वाला V is equal to you can write this is D. dt cancel होगा. This is epsilon 0 A. When you find what is displacement current, id is dq by dt. That is epsilon 0 A dE by dt. This is id. And what is current density? Current density JD is equal to id by A. Area आएगा epsilon 0 dE by dt. Okay. So this is Maxwell's equation in a differential form, and it is suggests that the electric charge in a closed circuit is capable to produce and varying electric field. It suggests magnetic monopole does not exist. It suggests induced EMF is capable to produce a magnetic field. It's not it. The curl, the rotation, which is perpendicular to the plane containing the magnetic field, and electric and magnetic fields are perpendicular to each other. It also suggests the current can be possible in case of a vacuum between two plates of a capacitor, and the current, total current, is contribution coming from the electronic current as well as the displacement current. Okay? Then we will go to the integral form. Okay? This was the differential form. Then the integral form of these equations suggests, integral form तुमको suggest करिबो that what are the integral forms? The first integral form, can I erase it? Integral form suggest करिबो जे integration first equation. This is the integral formula. Integration over v. ये गपना बात ये भलो रहउची नंबर सबरन dv 1 by epsilon 0 integration over v rho into dv no first equation. The second one is integration over v del dot b into dv is equal to 0. And this equation leads to E n cap to जो start करते हैं q by epsilon. नहीं, and the third integral form is here curl E n cap ds curl E n cap ds minus d by dt b n cap ds. Okay. And the fourth equation you have already found. This is the integration over closed surface. B dot dl is the RHS side, that is mu 0 j plus mu 0 epsilon 0 d phi by dt. And you find none of these equations are symmetric. None of these equations are symmetric. What are the key points of this equation? What are the features of Maxwell's equation? You know the physical significance. The features are like this. One, Maxwell's electromagnetic equations are coupled equations. Maxwell's electromagnetic equations, first one, like Maxwell's electromagnetic equations are coupled equations. And they define, second point, they define scalar potential and vector potential. They define scalar potential and vector potential. Potential. They are relatively covariant. covariant. Next, they are consistent with quantum mechanics. These equations are consistent with the Lagrangian and Euler-Lagrange differential equation. These equations derive wave equations and explains electromagnetic wave. Wave equations and explains electromagnetic wave. And explains electromagnetic wave. Then we will focus on some gauge transformations. That is Lorentz gauge and your Lorentz gauge and Coulomb gauge. Or Coulomb gauge is also called your transverse gauge. Pila, what do you mean by gauge? Gauge theory kahuchi Lagrangian does not change under a local transformation. Pila, locally tu gale kon kru? Man कर तू कटक जाऊँ बस धरी ये छकरू जदि जीवु से जो चंदन पोखरी छक को तू कौन बस धरिबु ना ये कोई उका पछर गोटे बसी पळे जाऊ तू र टिके जीवा मु मध्य जदि एउटु सेतिकी किछि बाट र टिके पछर बाबू मु जीवी से जाय similarly that local transformation of Lagrangian is possible by changing some variations. Say any variations of who? Variations of scalar potential and vector potential. Pila scalar potential और vector potential तुमको second year रे magnetism और magnetic effect रे पढ़ाई phi और ये विषय phi रो मूल्य से ठीक बुझे होची ताले that is called gauge ताले आगे gauge transformation कौन जाना लेखो हुए नहीं रे बाबू दे तुम्हें डिजाइन सब बड़े ये करछो Lagrangian लेखो gauge theory होची when a Lagrangian does not change under local transformation Lagrangian does not change under local transformation. Local transformation. This is called gauge transformation. This is called gauge. ए गोटे धाडी नु सब जानि परिबो. This is called gauge transformation. It regulates degrees of freedom in Lagrangian system. Lagrangian system in a configuration space. Configuration space. And what gauge transformation did? Our vector potential and scalar potentials are capable to find, evaluate or detect the value of electric and magnetic fields. However, the converse is not true. A and phi are capable to determine the value of E and B, but E and B cannot find the value of A and phi. Lekha here A and phi, A माने vector potential, phi माने scalar potential. लिखी दिया नाले. Here जितनी की पढ़ो जो तिक्के जाने सुनिए पढ़ो. Here vector potential and scalar potential A and phi determines E and B. E means electric field and magnetic field, but the converse is not true. But the converse is not true. But the